Hi guys, this is going to be the review, the first review homework and the first questions on that paper as a first response. And we have two cards, and one of them has a force sensor, the other has a spring attached to it. And there's a graph that shows you force and time relationship. And they also give you a function of force as a function of time, ft, as 3,200 t squared minus 500 t. So once you first look at the question, you should always try to guess what's it's about, what's the subject. For example, once you see force and time together, the first thing that should come to your mind should be impulse momentum, because once you figure out what it's about, then you are going to be able to actually think about the equations and the questions about impulse momentum, so it's going to be easy for you to figure out where to start from. So once you have force as a function of time, it looks scary, I know, because there's a function, it's not like just a number, but you don't need to get scared from questions related with functions, because in the equation sheets you will see some derivatives and integrals. Try to use some of those equations. So and let's see what's they're asking for in the first part. In the first part, they are directly asking for the impulse, and then they ask you to use integral or calculus to figure that out. So once you look at your equation sheet, you will see a equation I or J. They mean impulse, and then you will see something like this, F dt. So what does that mean? Force function, and the integral of that force function with respect to time is going to give you the impulse. So all you have to do is basically take the integral of that function with respect to time. And since your force is a function of time, then it's going to be an easy integral. So let's see what's happening. 3,200 t squared minus 500 t dt. So we replace our force into the equation, and that's all we need. So here there is one important thing. Remember, we always use boundaries because we're going to have a start time and end time. So this is a function, like a general function, but we are going to need that force function for a certain amount of time. So it's going to start from 0, and if you look at the graph, it is not going to go till infinity. It's going to end at 0.16. So I am going to evaluate that force function from 0 second to 0.16 seconds. So if I evaluate it over that range, then I'm going to be able to figure out the force times delta t, basically, which is impulse, which is change in momentum. All right, let's do that right away. So 3,200 is just a constant, so you have t squared. What will be the integral of t squared with respect to t? It is going to be basically, remember, increasing the power by 1 and divide it with the same power. So t cubed divided by 3. And do the same thing for the other part. Negative 500, increase the power. Power is invisible 1, so it's going to be 2 divided by 2. And I'm going to evaluate it from 0. Well, I already took the integral, so I'm going to evaluate it from 0 to 0.16. Alright, so that's what I'm going to do. So after this, what am I going to do? All I need to do is replace 0.16, the upper boundary for the variable, which is t, and then minus, put the lower boundary into the place, and then see what the difference is. So let's write this down real quick. 0.16 cube minus, well, over 3, 500.16 square divided by 2. So this is once you replace the upper boundary, so this is the function that you have, upper boundary minus, you plug in the lower boundary, and I am going to write this down over here so that I'm going to have space. So I continue this over here. So that's minus 3,200 0 cubed divided by 3 minus 500 0 squared divided by 2. Because I replaced this t, the variable, with the upper and lower boundary. Up there, I replaced it with the upper, 0.16, and up over here, I replaced it with 0. So, and the actual test, you might not need to do that because that's going to give you 0. 0 times any number and divided by any number will be 0. So lower boundary, you have basically 0. So you subtract nothing. So all we need to do is just calculating this equation. And once you look at the equation, or once you solve that, once you put that on a calculator, you will see that this 0.16 cube is going to give you a really small number, 0.04696 minus, and divided by 3, minus 500 times 0.0256 divided by 2. And once you plug in all, like once you do this last part, then what are you going to find? You're going to find this as 437 minus 6.8, and your final number as a result, I or j, is going to be found as, so you're going to subtract a larger number from a smaller number. It's going to be negative 2.03 kilograms meters per second. So this is the impulse that you are going to find. So in part B, they're asking for speed of the cart after the collision. So remember, impulse is going to be basically change in momentum of the object. So since change in momentum, the impulse is negative 203, then that's supposed to be equal to the change in momentum of the car. And that is basically m times delta v, because your mass is not changing, your velocity is changing. And remember, momentum is mass times velocity. Change in momentum will be mass times change in velocity. And initially, so if you rewrite this equation, 0.03, mass of the cart was given 0.5. So delta v is always final minus initial. So we do not know our final velocity. That's what we're trying to figure out. And initially it was given as 3. So we are basically going to solve this equation for v final. So if you divide both sides with 0.5, then you're going to get negative 406 equals v final minus 3. And if you add 3 to both sides, your v final will be found as negative 106 meters per second. Do never forget your units. So as you can see, it is a straightforward thing. All you need to know that impulse is equal to change in momentum. And then just plug in the numbers into the place. In part B double I, so they're asking for the direction of the car after the collision. And be careful, they are not asking for a justification. All they ask is the direction. So once you look at the sign, it's negative, and that already indicates that it's going to the left. So all you have to mark is just left. And that's the answer. So CI is asking for calculate the speed of the car to after the collision. So now we are going to calculate the speed of the second cart. So how are we going to be able to do that? So we can simply use the conservation of momentum over here, because this force is going to act during the collision, and this is part of the system. So my momentum is conserved because there's no outside of force in my system. That means my total momentum, initial of the total system and final, must be equal. So then what does that mean? P1 initial plus P2 initial must be equal to P1 final plus P2 final. So I already figured out the velocity of the first car before and after. I know the initial velocity of the second car. All I need to find, and I know the mass of everything, so all I need to do is just solve it for the velocity of the second car. So Pi is basically mass of this object, which is 105. Nope. Mass of the first object, which is 0.5. And velocity of this guy, it's going to the right and it's going with 3 meters per second plus 105 of the mass of the second cart, but it is at rest at the beginning, so it is 0. And P final of the first object is going to be, again, mass is the same, 0.5, but this time it's going to be going with negative. You should be very careful with that sign because that's going to change the result. Negative 106 plus final momentum of the second cart, which is again the same mass, 0.05, times a velocity that we do not know yet. So if you do all of the calculations, you're going to have 0 over here, so 3 times 0.5 will be 1.5, and that is equal to 0.5 times 106, which is negative 0.53 plus 105 V final. So we are trying to solve it for V final again. So what are we going to do? We're going to add 0.53 to both sides. And once we do this, we are going to find that 1.5 plus 0.53 is basically 203 equals 105 V final. So if you divide both sides with V final, 105, then you find your V final as 1.93 meters per second. In CII, they are asking you to show that that's an elastic collision. It means that energy is conserved. So all we need to do is see if initial kinetic energy equals to the final kinetic energy. So you basically see if delta K, change in kinetic energy, is 0. Alright, that's what you're trying to figure out. So if this is equal to 0, then you are going to be able to say, okay, that's an elastic collision. So that means we need to, delta K is basically K final minus K initial equals 0. So what is K final minus K initial? We are talking about a system, so K final of 2 plus K final of 1 minus K initial 1 plus K initial of 2. So that difference is supposed to be 0, but we don't know if it's 0 or not, so that's what we're trying to figure out. So I just put a question mark on the equation, like equal sign, to represent that we are testing if it's equal or not. So what are we going to do? We're going to write down the kinetic energy equation for every single one of them. So it's just going to be long, so I'm not going to write down the entire 1 over 2 mv squared for each one of them. I'll just go with the numbers. So final kinetic energy of the second object. So what's the final kinetic energy of the second object, or second cart? So 1/2. My second cart is 0.05 mass times velocity. What's the velocity of the cart after the collision? It is, we found that it's over here, 193 square. So this is the kinetic energy of the second cart after the collision, plus kinetic energy of the first cart after the collision. So 1/2, 0.5 is the mass of it, and velocity of this cart is, after the collision, negative 106. Negative 106 square. And this is my final kinetic energy. And then I'm going to subtract my initial kinetic energy. So initial kinetic energy of the first cart is basically, again, 1/2. The mass of this cart is 0.5 times velocity of that cart before the collision was 3 square plus kinetic energy of the second cart before the collision. It was staying at rest, so it is just 0. So just close the parentheses and then see if this is equal to 0. So all you need to do is do the math over here after the collision part, basically. After you do all of the calculation, you will see that this part of the equation will be equal to 0.281, and then plus, you will see that this part is equal to 1.956, and then minus, once you do the math over here, you will see that it is equal to 2.25, and then you're still looking for if it's equal to 0. So once you add all of them, you will see that this part is equal to this part is equal to 2.24 minus 2.25. So is it equal to 0? It is basically 0.01. So you can roughly say that's equal to 0. So you just show that this is, or that's like 99.9% elastic collision. DI. So they're asking for the speed of the center of the mass. Alright, so center of mass of the basically total mass after the collision is given as total momentum mv divided by total mass, basically, of the system. So total momentum of the system means m1v1 plus m2v2, and total m means m1 plus m2, basically. So which part are we going to look at? Are we going to look at the before or after collision? To be honest, that doesn't really mean it. I mean, it doesn't change the result. Both will give you the same result, but I'm going to use the one before the collision. So it's m1v1 plus m2v2, and total mass is basically m1 plus m2. So what's my mass in the first place? 0.5. And what's my velocity before the collision? 3 plus what's my total momentum before the collision? I mean, a total momentum of the second car before the collision? 0. And what do I have as a mass? 0.5 plus 105. And once you do the math, what are you going to get? 1.5 divided by 1.55. And that is going to give us 0.97. And this is basically velocity, so it's meters per second. Alright, so velocity of the center mass throughout the collision. Remember, it stays the same throughout the collision, so before or after it's not going to change anything. So you can also use the values for the after collision, it will still give you the same result, so nothing's going to change. So that's your DI. In DII, what do they ask for? They are asking for the maximum elastic potential energy on the spring. Well, there are a couple of ways to do that, but I think the easiest way of finding that is going to be through the graph, because once you think about maximum elastic potential energy, when are you going to have it? Once you compress it the most. So once you compress that the most, what are you going to expect to have in terms of force? you will also have the maximum force, because to be able to, as you compress more and more, remember force equals negative kx. So as you compress that more and more, you're going to need more and more force. So once you look at the graph, you will see that your force, the maximum force that you have, is around like 0.08 second, and it's roughly like negative 20 newtons. So you can estimate that. So negative 20 equals negative k, and k of the spring was given as 130 times x. So if I find my x, because remember, what is elastic potential energy? It's 1/2 k x squared. So if I know how much I compressed it, then I can find how much energy I stored, like elastically. So then this equation is going to help me to find my x, and then I will just plug it into that equation, and then I will be able to find the energy that I stored. So divide both sides by negative 30, 130 actually, and then that cancels out. So negative negative makes it positive. Remember that negative sign is just to describe the direction of in between like x and force. So they're always going to go in the opposite direction. So then my x is going to be positive number, and once I divide that, I find my x as 1.15 meters. And all I need to do is plug in that 0.15 into the equation, and then once I do this, 1/2, 130, 1.5 square, and once you do that, you will find that the actual number. So actually that's 153 meters, and then I calculate it with 153, and then once you find it calculated with 153 square, then your answer will be 154 joules. Alright, so that is the solution for the first question in your homework.